Okay, so I got a request for homework problem 15.7, and I'm going to take a little extra time with this because this is some good review for a couple things. But first of all, the question stem. I'll write this out. The homework problem 15.7, right? Okay. So the question stem says, all right, if the wave function for a two-dimensional particle in a box is n, sine this, sine that, right? Then what we're asked to do is obtain an expression for the energy, nx, ny, and this is just essentially the energy, right? In terms of nx, ny, a, and b. Okay. So just as a word of review here, first of all, this is the normalization factor. And as I was thinking about this, I actually calculated the normalization factor, and at the end realized I didn't need it. So I'm going to leave this out for now, and you will see that it just ends up being, n in the end. But there is a normalization factor, and here's this. This ought to look familiar to you. This would be the wave function for a one-dimensional particle in a box. And so if the second dimension is y, it's going to take on the same form. And of course, you can imagine that a three-dimensional wave function would also exist. You can imagine what the form of that would be. All right, so if we're calculating the energy, and this is the wave function, and we're just going to use the Schrodinger equation, right? H hat psi is going to give us E hat psi, assuming, of course, that this is a eigenfunction of that operator, which we'll prove to ourselves in just a moment that it is, although you may have just memorized that it is. Okay, so that's sort of where we are. That's where we're starting out. Let's remind ourselves let's review what H hat is for a particle in a box. It is minus h bar squared over 2m dx, right? Second derivative of that. And if it's a particle in a box, then we're assuming that it's that the potential outside the box is infinity, the potential inside the box is 0, so we don't have a potential term here. Now, if it's two-dimensional, then we're going to have a second term, right? You're going to have the energy for the first and the second, and then we factor that out, and we get like that. Okay, so this is the same thing. I guess let me just go back a step. This is maybe how you would want to see it. Dx plus minus h bar 2m dy, right? And all I did here was I just factored out these two constants. Okay? So this is the one I'm going to use. Let's take this now. Let's take this wave function and apply this operator to it. And it's going to be long, but let's do it. Okay? Second derivative of psi is going to give us minus h bar squared over 2m. Now, when we take the you take the derivative with respect to this whole thing, all it's going to do is differentiate that. It doesn't do anything to that, of course, or of that. So let's take the second derivative of that. Let's take the first derivative. Let's do it one step at a time, just in case you need to see that. So this is going to be. I'm going to leave the first. This is the second one. The first one I'm going to go ahead and do. It is n cosine n x pi x over a sine n y pi y over b, right? But I forgot to put that term in there, so it's going to be nx pi over a. Okay? Plus d dy n sine nx pi x over a cosine, because I've already taken, this is the first derivative, and here's my second one, right? But I'm taking the first derivative first. Ny pi y over b, and then ny pi over b. Okay? Wow, a lot of terms there. All right, now let's take the second derivative now. And I'm going to go ahead and pull this guy out front, up next to that n. Okay, and so here's my terms. This is only going to differentiate that. It's not going to touch that. So let's do that. And 2m n, I'm going to put that term out front, nx pi over a. Actually, if I'm doing the second derivative of this, it's going to pull that guy out again. Alright, so let's make that squared. And it's going to be sine, except it's minus this time, right? Because the ddx of cosine of some x function is going to be negative sine, right? So there's my negative sine. Nx pi x over a sine ny pi y over b. Okay. And this one's going to be the same thing. I'm doing the dy now of this cosine of y function. So it's going to be a minus sign. So I'm going to put the minus right here. Minus n, and I'll pull that constant out front. Ny pi over b. It's going to be squared because we're taking it out a second time. Sine n x pi x over a sine ny pi y over b. Wow, okay. It's getting better, I think, maybe. Okay, now it looks like I've got negative n. I can pull that out twice. I'm going to pull this n out front. No, you know what? That's part of the wave function. Remember, from the wave function, that's n. So I'm going to try to make our wave function fall out of this. So let's go back here. And it turns out there, and there, and there, and there, right? I've got two terms here. Negative n blankety blank minus negative n blankety blank. So if I pull that out of both terms, it's just going to be psi. This is h bar over 2m. Oh, you know what? I'm going to take those minuses out too, make that a plus. And so this is going to give me nx pi over a squared minus ny pi over b squared. And that whole thing times psi, because that's just psi, right? Wow. Okay, so this must be my energy then. This right here is my energy. So let's simplify this, and that's really a form of the answer. It's not the prettiest form. I've got a pi here in h bar, don't I? So I can pull that pi. Matter of fact, it's pi squared, and there's a pi squared. So I can simplify this. This is going to be h over 2 pi, because remember, h bar is equal to h over 2 pi, right? So this is h. That's my h bar. 2m. Okay. And nx pi over a. Let's make all these squared. Minus ny squared pi squared over b squared. I know, I'm going the long way. H squared 4 pi squared 2m nx squared pi squared over a squared minus ny squared pi squared b squared. Okay, it looks like my pi squared terms can cancel. I can combine those, that 4 and that 2. So this is going to be h squared over, let's get rid of those guys, This is 8m. Just took care of all that. There's my h squared. Okay. So it's nx squared over a squared minus ny squared over b squared. Boom. Wow. And that is the energy. Made up my own energy formula. Gorgeous. Okay, so that's problem 15.7. Really, it's problem 15.7a. B is a whole different kind of problem. We've talked about that. I feel like I've made a video of that. But if you want to see B, 15.7b, then please make a request. I think that is something that's a little more maybe intuitive. So, okay. The answer is this is equal to that mass right there. Hope that's helpful.